So the parts that we have to fill in for these exponential equations are, these might be a vertical shift, an upside down, an up down shift, and this is some kind of stretch factor, and then there might be some kind of reflection where it's a growth equation that's been reflected or a decay equation that's been reflected. So what you have to do, and they don't tell you, like for this equation, this is on page 241. They don't tell us what the base function is. So we're going to have to find A, we're going to find B, and we have to find K. So what I'm seeing here, I know normally exponential functions have the x-axis as a horizontal asymptote, and even if it's been reflected as this one in number 33 has, okay, it's been reflected, so we know A is going to be negative, but it's also been shifted up. So instead of having the horizontal asymptote around the y-axis, x-axis, it's been shifted up here to 7. Okay, so I know that tells me K is going to be 7, so I can write y equals ab to the x plus 7. Now I want to pick a couple of points. Well, this is a nice point to use. That tells me the y-intercept is 0, 5. So let's use that. So 5 is y. A times b to the 0 plus 7. Well, b to the 0 is 1, so that leaves me 5 equals a plus 7. So it must be a equals negative 2. So that we kind of knew it was going to be that kind of reflection. So y equals negative 2 times b to the x plus 7. And now we need to pick another point. I think that point works pretty well, 1, 1. And this will help us find b. So y is 1, negative 2 times b to the first plus 7. So I'm going to subtract 7, gives me negative 6 equals negative 2 times b, because b to the first is 1, and b to the first is b. Then I divide by negative 2. That tells me b is 3. So I think the equation for this graph, let's see if I can do some erasing here. I'll change that to a different color ink. So I think it is, let's see, negative 2 times 3 to the x plus 7. Okay, so that's number 33. You can look at the answer in the book here to see that, but they have some pretty good walkthroughs. So I'll come back and do number 35 now. So in this one, I see the horizontal asymptote's been shifted down to y equals negative 4. So that tells me f of x equals a times b to the x minus 4. Notice that's the first thing I'm doing, is finding that horizontal asymptote for these exponential functions. And then what do we have? We have that point there, 0, negative 2. So negative 2 equals a times b to the 0 minus 4. I'm going to add 4. That gives me 2, and b to the 0, of course, is 1. So it looks like a is 2 in this problem. So f of x equals 2 times b to the x minus 4. And then we can pick another point, and this x-intercept of negative 1, 0 looks like it'll be promising. So let's try that. So 0 equals 2 times b to the negative 1 minus 4. So I'll add 4. That leaves me 2. And actually we can treat this like this. Why don't we treat this just like this? I think that'll make it easier for other problems. So b to the negative 1 is the same as, so 2 times b to the negative 1 is the same as 2 over b. Remember, negative exponents means we can kick them downstairs. So now all I have is a proportion. I can find the cross products. So 4 times b equals 2 times 1. And then I'm going to divide by 4, so b equals 2 over 4, or 1/2. So we're thinking this equation is, can I erase that? Will it let me erase it? Nope, looks like that's passed. So y, or f of x, equals, let's see, I said a was 2, b is 1/2, and to the x minus 4. And if you think about this, this is just a decay equation that's been shifted down 4 units. and stretch. It's got the stretch going on too. But so that's how you do these kind of problems. Find your y-intercept, find a point. Typically, the y-intercept will help you find the a, that leading term there, that leading coefficient, and then pick another point, and that'll let you find the base if you don't know the base. Okay? Hope that helps.